All right, folks, it's Bass Action back in action here. On this page of notes, we are going to take a look at finding an inverse of a matrix. And in order to find an inverse of a matrix, we are going to need to learn what a determinant is and how to get that. We are going to use our inverses actually in the next video, on the next page of your notes, to actually solve some systems of equations, specifically our systems with two variables. So let's dive into these, looking up here at the top of the page at our inverse matrix and a determinant. The inverse of a matrix, say we're going to call it matrix A, is going to be denoted by this a to the negative 1. This is very similar notation to what we used for our inverses for our functions. So what we want to first understand about an inverse is that when our inverse, in this case our matrix A, is multiplied by its inverse, so when we have our matrix multiply the inverse of that matrix, our product will be an identity matrix. Now, an identity matrix is a matrix that looks like this right here. An identity matrix has 1s on the diagonal and 0s in all the other places. Now, these identities are going to be important because if we multiply, remember, something by the identity, it doesn't change its value. So what we also want to understand when we're thinking about our inverses is that only a square matrix, okay, can have an inverse. However, not all of our square matrices will actually have an inverse. So it has to be a square matrix, but that doesn't guarantee that there will actually be an inverse that you could use. So to actually find the inverse matrix, we need to understand the determinant. Okay, and we're going to have a simple little formula to follow for our determinant. You just really have to kind of keep track of a couple values. The formula for our determinant is the product A times D minus B minus C. Now you have to understand where the A and the D are coming from and the B and the C. So the A and the D are coming from this diagonal and the B and the C are coming from the opposite diagonal. So if we can find the determinant, then we could find the inverse. Now, you'll notice if you're looking ahead at all on our formulas here, you'll notice that our formula for our actual inverse over here is going to involve the reciprocal of this determinant. That's why, if you look at my note right above here, that if the determinant is 0, then the matrix isn't going to have an inverse at all, because I obviously can't do the reciprocal of 0. So that's going to be an important piece. So I'll come back to the rest of that formula in a moment. So let's take a look at our example down below. I'm going to slide this up a bit. So we're going to take a look at this example. I've given you a matrix E, and we want to find our determinant first. So if we want to find our determinant, remember we're going to do this product, and then we're going to subtract this product. So when we go to write our determinant, I'm going to do 6 times my 4, and I'm going to subtract my 3 times my 10. Okay, so that's going to give me a 24 minus 30, or in other words, a negative 6. So that's my determinant. It doesn't equal 0, so I can continue to actually find the inverse. So if I want to find the inverse of my matrix E, I remember I'm going to denote it with this e to the negative 1. Looking up above, I know that I'm going to need the reciprocal of my determinant. It's important to remember it's just the reciprocal. We've got to keep that same sign. So I'm going to have a negative 1/6. And then I'm going to treat that as a scalar, and I'm going to multiply it by a modified matrix. So let's take a look up above here and what that modified matrix is going to look like. What I can see is that A and D are going to change places. Okay, so those are going to flip-flop. And then what I'm also going to notice is that the C and the B change signs. So we have to make sure to write the modified matrix and not the original matrix. So my modified matrix of my matrix E, I need to reverse the A and the D, so that's going to be a 4 and a 6. And then I need to change the signs of B and C, so a negative 3 and a negative 10. Now, I'm just going to treat this like a scalar like we saw in the other video. So I'm going to take that -1/6, distribute it to every element, and then of course simplify. So as I distribute that -6 all the way across, or -1/6, I'm going to get a -2/3. I'm going to get a 5/3. I'm going to get a +1/2, and I'm going to get a -1. So this matrix right here is my inverse. That is my inverse. Now, if I am asked to verify my inverse, okay, so let's say I'm asked to verify the inverse, what I'm going to remember is that if I take my original matrix E and I multiply it by its inverse, I will get the identity matrix. So this gives us an opportunity to practice our matrix multiplication. So I'm going to slide this up again so that we have a little bit more space to do this matrix multiplication. All right, so we need to multiply our original matrix E times our inverse. So if we want, we can even write that out. That would be a helpful thing for us to do. We are wanting to multiply our 6, 10, 3, and 4 times this inverse matrix of a -2/3, 5/3, 1/2, and a -1. Now, remember our matrix multiplication says that we need to take this row times this column and this row times this column. And then we're going to do this row times this column and this row times this column. So as I showed you in the other video, what I often like to do, it helps me to just kind of space things out. I write the 6, and I'm going to give myself a gap here, and I'm going to write my 10, and then I'm going to write my 3, give myself a good gap, and I'm going to write my 4. Then I'm going to give myself a big gap over here so that I've got space between my values, and I'm going to rewrite again my 6 and plus my 10, and I'm going to write my 3 plus my 4. This is going to help me keep track of this row and this column and this row and this column. So then I can go back and I can fill in those columns, okay? So I'll have my -2/3, and I'll have my 1/2, and I'll have my -2/3, and I'll have my 1/2. And then I got to do my other column, so I'll have my 5/3, and I'll have my -1, and I'll have my 5/3, and I'll have my -1. Very repetitive here. All right, so that gets me my expanded view of my matrix multiplication, and we can even write our middle step here. So if I go through and I just follow this arithmetic, okay, just simplifying each of these, I will get a -4 plus a 5, and then I'm going to get a -2 plus a 2. And you could certainly pause this video and fill these in and make sure, check your answers, and you'll get a 10 and a -10 and a 5 and a -4. Certainly you could write those as subtraction if that makes you feel better. I just wanted to remind you that we're adding. So as I clean all of that up, of course my -4 and 5 is going to give me 1. My 2's right below it are going to cancel each other out. My 10's are going to cancel each other out, and my 5 and my -4 gives me my 1. So this was exactly what we were looking for in terms of our verification of our inverse. So that's all we've got. And then on the next page, we are going to actually work through and see how we can use that inverse to actually solve a system of two variables.